Okay, so hello everyone. Hello everyone. So basically in this video, we are going to see that how we can optimize a Python code with NumPy. Okay. So basically this total notebook is going to says how to optimize Python code using NumPy. Basically here we are going to highlight some different types of things like what is the difference in speed, memory, uses, and convenience between standard Python and NumPy operation. Okay, if we are going to use a Python function or a code for doing something, so what is the difference between Python codes and NumPy codes? Okay, it's basically how this all things are going to work. We are going to see that in this video. So basically, if you see, so in this video, what are the things we are going to cover? So basically, first the thing is, what is the NumPy? We will start from the introduction. Okay. Then why we use NumPy? Okay. The second, our basically topic will be, then we are trying to compare Python list versus NumPy arrays. What are the difference between Python list and NumPy arrays? What are the difference between Python data structure and NumPy data structure? How they both are works? Which is more efficient? Which work very fast? Which use a less memory to store the data? This all things we are going to see. Then we will see that how we can convert any data into a vector. Okay, how we can do a broadcasting, what is the memory efficiency, okay, what are the performance benchmarking, we will see that, and then based on this all things we try to give a conclusion. Okay, so let's start from the introduction. So first the thing is, if we talk about what is the NumPy, so NumPy is basically we can say that numerical Python library, which is a very powerful for numerical computing in Python or a numerical operation. Whenever you want to perform a numerical operation, you can easily use a NumPy library. Basically, it's provide supports for arrays. You can easily create an array by the help of NumPy. You can easily create a matrix, and you can use many of mathematical function by the help of NumPy. Okay. So basically, when you want to use a NumPy, what you have to do? You have to first call the NumPy in your system. Okay. How you can call it? So first you have to write an input, then NumPy, which is your library which you want to use. Okay. Then you have to give a alias name. Alias is nothing but a AS as NP. So basically, instead of writing a NumPy, we are going to write NP and NumPy will become. Okay. So once you import it, let's see why we use NumPy. So basically, it is a very fast computational. Okay, it's very fast computing your code. It's very less uses of memories. Okay, it is a convenient syntax. Okay, instead of that, it's basically there is a lots of inbuilt function for a mathematical operation, which is a advantage of a NumPy library. Okay. These are the some things which we are going to use. Because of that, we are going to use a NumPy library. Okay. Then let's see, and we try to cover up how we can see that which one is best, which one is taking very less time for doing any operation. Where we will try to compare Python list and NumPy arrays. Okay. If you see, so here what we have to first, I'm importing a time so we can easily see that what is the time uh Python list data structure is taking for doing some works, and what is the time taking from the NumPy library, okay, for doing a same. Okay, so for that, here I am importing a time. Then I'm creating a one variable where I am putting this value. Okay, I'm giving a some value, which is nothing but a 10 lakhs. Then what I'm going to do, I'm taking a range of this 10 lakhs. Okay. I'm taking a range of this 10 lakhs, means 9 lakh, 9,999 will be my range. Okay. It will start from the 0 and it will go 9,09,999. And whatever value I'm getting, I am basically storing into and converting into a form of list. Once I convert into a form of list, then what I'm going to do, I'm going to store this all value of a list into a variable list one. Okay. Same things I'm doing here. Again, I'm taking a range of same this value, which is nothing but a size. So I'm here taking a range of size and then converting this all value into a form of list. After once completing you this all value into a list, what I'm going to do, I'm going to again store all the value into a variable list. Okay. Once you have a list one and list two where you have a value starting from the 0 to 9,09,999. Now the thing is, I want to see what is the time it's taking. Okay. So for that, what I'm going to do, I'm going to call time parenthesis. So here, what I'm going to do, I'm going to call a time, then then I am calling from the time package time parenthesis. So it will what it going to do is will start my time, and whatever time will start, I'm storing that time into a variable start. Then I'm writing a for loop x plus y. Okay, x plus y, whatever the value of x and whatever the value of y will be added, and then I'm writing a for loop for x comma y in zip of parenthesis list one comma list two. Okay. And whatever value I'm getting from here, I'm storing that all value in a list. Then I'm stopping the time. Time dot time parenthesis. Okay. So what it will do, it will calculate the end point. Okay. What is the time it taking from here to here? And whatever time here I'm getting, I will store into a end variable. Then by the help of print function, I'm calling a Python list time into a form of a string. Then what I'm going to do, I'm going to differentiate it, how much time it takes for run this code. Okay, end comma start. So I will get an actual value. What is the time taken from the list data structure for this operation, individual operation? Same things, same things. What I'm going to do, I'm going to do this all same things by the help of NumPy. So np dot, I'm calling a NumPy dot arrange function is also work like a range, but arrange will be give me all the number within a form of array. So that's for I'm using here arrange. And again, I'm giving a parenthesis size. So again, here it will same work of like a range function. Okay. It will taking a starting point as a 0 and it will start as at a 9,09,999. Okay. 9. And whatever value here I'm getting, I'm storing into a variable ARR1. Same things. Again, same value I'm storing into a ARR2. And what I will do, I'm going to again add this both number. Okay. So for that, what I'm going to do, I'm starting writing a code time parenthesis. So it will start my time. And whatever time will start, I'm storing into a variable start. Then I'm calling a ARR1 plus ARR2. So this operation, for this operation, what is the timing it taking for? Okay, what is the timing this NumPy will take? So whatever the code I am executing here, I'm storing the all the result into a variable result. Then once it done, then I'm going to stop the time, or we can say that I'm going to calculate the time again. Okay, so time dot time parenthesis. And whatever time here I'm getting, I'm storing into a variable n. Then by the help of print function, I am again differentiating for getting an actual value of for this operation, what is the actual value I want to see? So end minus start. If you see here, if you see here, so you will get that Python list time is taking 0.08, but when you see a NumPy array time, it is taking 0.01. How it's working fast compared to a Python list data structure, right? So basically, here we can easily see that the NumPy array or NumPy operation is a very fast compared to Python data structure. Or we can say that NumPy data structure is very fast compared to NumPy Python data structure. Okay, we can easily say that NumPy data structure is very fast working compared to Python data structure. Okay. Next, the thing is how we can convert any value into a vector. So for that, what here I am going to do, I want to see that how this all things is getting. So vectorization also allow NumPy to execute operation without explicit loops. Okay, it's really simple. How we can do that? Again, I am calculating the time dot time. I am starting the time, and whatever time will start, I am storing that time into a variable start. Okay. Then I'm writing a for loop x asterisk asterisk 2 means a power of x is nothing but a 2. Okay. Then for x in range size. Okay. For x in range size. And whatever value here I am getting, I'm storing into a variable s5, and then I'm stopping the time. So for that, I'm calculating the time. What is the time it's taking for start and end? So time dot time parenthesis, and whatever time I'm taking, I'm storing it to a variable end. Then print a square time end minus start. So I will get the actual value. For same things for a NumPy, what I'm going to do, I'm writing a code time dot time parenthesis. So I will start my time, and whatever time will be, I'm storing into a variable start. Then same things np dot arrange. I'm giving a size. Then again for size, I'm getting a power of 2. Okay. So whatever code here I'm writing, for that, whatever value I'm getting, I'm storing into a square underscore np. Okay. Then I'm stopping the time for calculating from starting to end. What is the end time? So time dot time parenthesis, and what is the time I'm getting? I'm storing into a variable end. Then for getting exact value, I'm differentiating it. End dot start. So if you see for Python square, it is taking 0.34 microsecond. Okay. For NumPy square time, how much time is taking? 0.003. Okay, how the NumPy is very fast compared to a Python, right? It's working very fast, right? So because of that, we are saying that the NumPy is a very fast, very powerful library where you can easily work. Okay. Now come to the broadcasting. Broadcasting is nothing but when you have a array or when you have a vector, when you have a matrix. So for that, if you are applying some another things, okay, you try to convert that value into a different way. That is nothing but a broadcasting. If you see here, broadcasting allow NumPy to work with arrays of different shape during arithmetical operator. Okay. For example, here if you see what I'm going to do, I'm creating a one dimension array, which is nothing but a vector np.array. Inside parenthesis, you have to give a square bracket, and here I'm writing some value like a 1 comma 2 comma 3. So it will be my one dimension array. And whenever you have a one dimension array, that is nothing but we are going to call it as a vector. When you have a more than one dimension, when you have a row plus columns, that time you are going to call it is nothing but a matrix. So here we have a vector, which I'm going to store into a variable A. Then what I'm going to do, I'm going to create a one more variable, which is B, where I'm storing a value 2. Okay. Then what I'm going to do is I'm going to apply a multiplication into my array A. Okay. So A into B. So what it will do, this 2 will multiply will each and every value of array. So 1 into 2, what will the output 2? 2 into 2, what will the output 4? 3 into 2, what will the output 6? Right. And then we are getting a value like a 2, 4, 6, which is nothing but 2 comma 4 comma 6. Okay. These are the value which we are going, and this is the work of basically broadcasting. Okay. Where you are going to apply arithmetical operation in some kind of array. Okay, or different types of shape, different shape of array. When you are applying arithmetical operation, that is nothing but a broadcasting. Okay, if you see here how the memory it's uses by the help of in Python or NumPy. So for that, what you have to do, you have to first import system. So here I'm writing importing a system, import sys system. Then I'm taking a range of 1000 into a form of list and storing into a variable py underscore list. Okay. Then again, I'm taking a range of 1000 in a form of array. Okay. Where I'm storing a variable np.array. Then I'm calculating the size, how much space my system is taking for storing this py underscore list value, how much my system is taking time, or basically how much my system is taking space for storing that all value into a variable np.array. So I'm calling a system sys.getSize of parenthesis. I'm providing my variable name where I have stored all the value. So it will tell me how much bytes is taking. Okay, same like that. For np.array, again np.array dot n bytes. It will tell you how much bytes is taking for storing all this value in a form of a range or an array for storing into a np.array variable. If you see it, you will see that Python list size is taking more or huge 2x compared to NumPy array size. Okay. Where the NumPy is taking only 400 or 4000 bytes for storing all same value. But instead of NumPy, if you see in a Python list is taking 8056 for storing the same value in a form of list, right? So you can easily say that, see that how how the memory efficiency you are getting that here, how you are using this. Okay. And because of that, it's working also very fast. Okay. Now, this thing is not important basically. So we will remove that. Then the conclusion is what? Using NumPy library, you can easily see that significantly improvement of the performance, okay, and efficiency of the numerical computational in Python. You can easily see that, okay, it's offer a more compact syntax and executes operation much faster than native Python list or another Python basically data structure types. Okay, so you can easily use a NumPy, which basically improve your model performance or improve your code's performance, which help you to run your code very fast compared to Python codes. Okay, or basically Python data structure code. Okay, it's basically take a very less time for computing all the execution. Okay, it's very fast compared to Python data structure. Okay. I hope this video helped you.